So we're looking at balancing equations today, and it's a key skill to have, and we need to know it both at GCSE and most definitely at A level, okay, because it is simple 1-2 markers which come up, and often I see students, they've actually done a lot of work for a 1 or 2 mark question by listing the number of atoms on both sides and so on, but I wanted to become more instinctive, that you can balance them using the conservation of mass, that the number of atoms going in has to equal the number of atoms coming out. So let's go through some examples, and the more examples we go through, the more, as I say, instinctive it will become. So what we've got down here, we've got 1 barium and 1 barium here, 2 oxygens here, only 1 oxygen there. And the way we balance equations, as you should know, is that you always put the number in front. So I need 2 oxygens here, I will never put a 2 there, the number will always go in front. So now I've got 2 oxygens, I've now got also 2 bariums, so I need to put a 2 there, and that is balanced. Let's look at this one down here. So what we've got 2 oxygens here, only 1 oxygen there. So if I put a 2 there, now the oxygens are balanced. Now I have to look here, I've got 2 2s, 4 lithiums here. So I need to put a 4 here to make that balanced, and that is fine. Let's look at this next one. I've got 2 nitrogens here, 2 nitrogens there. I've got 3 magnesiums, so I need to put a 3 there, and that's balanced. Let's look at this one. Now, whenever you've got an odd number of atoms, try to make them even. Okay, when you're balancing them from the side where there are less of those atoms. So, for example, you've got 4 chlorines here, I've only got 3 chlorines here. So if I put, say, a 2 here, so now I've got an even number, 2 3s are 6 chlorines there. I've got 2 ions. Okay, so if I put a 2 there, now I've got 2 ions and 2 ions are balanced. 2 2s are 4 chlorines there, 5 6 chlorines, 2 3s are 6, and that is balanced. Okay, let's look at some more complicated ones. I say complicated, I hope they aren't now, they're getting a bit more sort of natural, coming naturally to you. So what we've got down here, we've got 2 hydrogens, 2 chlorines. I've only got 1 hydrogen and 1 chlorine there. Let's put a number 2 in front of there. So the hydrogens are balanced and the chlorine. Whenever you've got something in brackets, I've got 2 lots of NO3 here. That means I need 2 lots of NO3 here. So if I put a number in front there, 2, that is balanced now. The NO3s there are balanced to the NO3s here. I've got now 2 Ags here, 2 silvers here. So I need 2 silvers here. Let's put 2 there. I've got 1 copper there and 1 copper there. Balanced. Let's look at this one down here. So you might think, okay, again, we're in that scenario. I've got an odd number. Let's make it even. Let's put 2 there. So 2 3s are 6. So that's a nice balanced number there. I've got 2 ALs there. Let's put a 2 there. Okay. Now if I've got 2 3s are 6 chlorines here. I need 6 chlorines here. So let me put a 3 there. So 3 2s are 6 chlorines there. I've got now 3 coppers there. And that is balanced. Let's look at this one again. I've got 2 lots of NH4. So I need 2 lots here. So let's put a 2 in front of there. Okay, I've got 2 chlorines there, 2 chlorines there, 1 zinc there, 1 zinc there, 1 sulfur there, 1 sulfur there, and that's balanced. Somewhere else you will have to look at balancing equations is when we start looking at combustion reactions. When we look at hydrocarbons, okay, or any organic molecules reacting with oxygen, how do we balance them? The simple rule is you balance the carbons first, then the hydrogens, and you balance the oxygens last. So here we go, we've got 1 carbon there, 1 carbon there, we'll leave that as it is. We've got 4 hydrogens there, I've only got 2 hydrogens here, so let me put a 2 there. Now I've got 2 oxygens here, 2 oxygens, I've got 4 oxygens, so let's put a 2 there, 4 oxygens there now, and that's balanced. Here we go, let's balance the carbons for this molecule here. So I've got 2 there, I've got 6 hydrogens here, so let's put a 3 there, 3 2s are 6. Now let's look at the oxygens. 2 2s are 4, 5 6 7. I've got 7 oxygens in total on this side, only 2 here. Now do not be surprised, you can use halves. So 3.5 oxygens here, and that's 7 oxygens on this side. I've got 2 2s of 4, 5, 6, 7 oxygens on this side. That's balanced. So you can use halves. Here we go. Here's another molecule. It's ethanol. And it's ethanol here. And so if we balance this, 2 carbons there. Let's put a 2 there. I've got 5, 6 hydrogens here. Let me put a 3 there. So 3 2s are 6 there. Let's balance the oxygens. 2 2s are 4. And then I've got 3 there, 5, 6, 7. So I've got 7 oxygens here. Now look, I've got this oxygen here already. Some students do forget that particular ethanol molecule or any alcohol with an O oxygen in the molecule, count that as well. So I've got 1 there. So I just need 3 here. 3 2s are 6, and that's 7. So that is balanced there. So I do hope you found today useful. Okay, today's session useful on balancing equations. It is a key skill to have, and the more practice you have just running through it, how we've ran through it today, okay, it's going to make a huge difference to you. And these are just 1 or 2 markers in an exam, but again, they can be time consuming. So we've got to find a way of actually instinctively doing it rather than writing atoms down on both sides.